Okay, today's lesson is all about basic operations with square root radicals. So we've talked a little bit about how to just take the square root of something. So for example, if you have the square root of 9, that's a terrible 9, hold on. That's equal to 3 because 3 times 3 is 9. So the square root of 81 would just be 9 because 9 times 9 is 81. So what we're focusing on today is how to simplify a radical when the number underneath does not have a square root. And so when you look at problem number 1 here, we're simplifying the square root of 20, and 20 does not have a square root. Now, if you're not sure, you can always use your calculator. Let me pull that up. And sure enough, when I type in the square root of 20, it gives me a decimal. Make this so you can see it a little better. So my square root button is here on the X squared button. They're in blue, so I hit my blue button. The square root and 20 is 4 point something. So when you have a decimal, that means that that number did not have a square root to start with. Okay. So what I need to do instead is think of some factors that divide into 20 that do have square roots. And matter of fact, I want the greatest factor. Okay. So first thing I think about when I'm thinking about factors of 20 is 4 times 5. Okay. 4 is a perfect square number. It has a square root of 2. So I write down the square root there. 5 does not have a square root, so it stays underneath the symbol. So radical 20 simplifies to 2 radical 5. Okay, let's look at another one together. This time we have the square root of 63. 63 does not have a square root, so I want to think of perfect square numbers that are factors of 63, and I want the largest one. Now, I do want to show you this little calculator trick. If you struggle a little bit with your multiplication tables, or say you're simplifying a number that's a little larger and you don't know the multiplication for that, when you look at your calculator, you can get a list of the factors of the number that you're trying to take the square root of by going to the Y equals button, which is on the top left side of your calculator. It should be the very first button there. If you have anything there, clear it out like I did. And then the number you're trying to take the square root of, or the number you want the factors of, in this case is 63, so I type in 63. Then I hit my divided by button, and then I'm going to hit X. X is the button right next to your green alpha key. Okay. Now, this is where we go to graph. We don't need the graph this time, but if you'll notice on that graph button there on the top right corner, you also in blue have something called a table. That's what we want. So that just means I hit the blue button and then graph. And if yours is not starting at 0, no big deal. You can scroll up and down to get it to where you want it. We want to start with 1. 1 and 63 are factors. For 2, do you see how I have a decimal? That means 2 is not a factor. And sure enough, 2 doesn't divide into 63 evenly because that's not an even number. 3 and 21. I could skip 4, 5, 6. And then I have 7 and 9. Okay, 7 and 9 look good because 9 is a perfect square number. Okay, so if I use 7 and 9, then like we said, 7 does not have a square root, so it stays radical 7. But 9 has a square root of 3, so that 3 goes in front. Okay, you all try 48. The square root of 48. You want to simplify radical 48. So pause the video, try that one, and then come back when you think you have the answer. Okay, if I use my calculator trick to get my factors, this one's a little tricky because when I look down through here, I might see 4 and 12, And yes, 4 has a perfect square number, but it's not my greatest common factor. Look up to 3 and 16. 16 is also a perfect square number, and it's larger than 4. So I'm going to use 3 and 16 instead. Okay. 3 does not have a square root, so that stays underneath the radical, but the square root of 16 is 4. So that tells me radical 48 simplifies to 4 radical 3. Okay, next set of problems are kind of the same, except we're going to throw in some variables there. So this time I want to simplify the square root of 128a to the 13th. So let's start with the 128. Okay, that one I definitely need a little help with my factors on. So I'm going to type in 128 divided by x. I'm going to go to second graph to get my table there. 1 and 128. All right, here we hit the jackpot. 2 and 64. 2 does not have a square root, but the square root of 64 is 8. So that part simplifies to 8 radical 2. Okay. Now, the next part that I need to deal with is this a to the 13th. Okay. Now, this means that I have 13 a's that I'm multiplying together. Ran out of room there, so I went to another line. Okay. So if we're multiplying 13 a's together and we're taking the square root, we want to know how many groups of 2 would I have. Well, here's a group of 2, here's a group, here's a group, here's a group, here's a group, there's a group. So I have 1, 2, 3, 4, 5, 6 groups of a's. So I can write an a to the 6th outside there. And then this a that did not have a group, it stays under the radical with the 2. That's a little messy to see, so let me write that again. 8a to the 6th square root of 2a. Now, here's the shortcut to that. If you don't want to have to write out 13 a's, that was a little bit of a pain. And imagine if you had like 20 something, it could get even worse. You're going to take this number, the exponent, divide it by 2 to see how many pairs you would have. We have 6 pairs with the remainder of 1. Your remainder of 1 goes here. That's a or a to the first. Your 6 pairs tells you what to put on the a on outside of the radical. Okay, here's one for you to try. The square root of 24 x to the 9th. So pause the video, you try that one, and then come back with me whenever you think you have it. Okay, for 24, I'm going to use 4 times 6. So the square root of 4 is 2. 6 doesn't have a square root. Okay. Then I forgot to leave myself room for my variable. Let me do that so I don't have a mess like last time. There we go. All right, then when I look at my x to the 9th, if I have 9 x's, how many groups of 2 is that? So I divide by 2. 2 goes into 9 4 times, so that tells me this is going to be x to the 4th. And then I have a remainder of 1, so that tells me an x goes under the radical with the 6. So 2x to the 4th, the square root of 6x. Okay, our next example, we're going to look at how to add and subtract radicals. Okay, radicals are considered to be like terms when they have the same type of radical. And if you'll notice, these are all square roots, and they have to have the same number under the square root. So I have a radical 7, a radical 7, and a radical 7. These are like terms. So think of this as how many radical 7s do we have? Well, here's 5 plus 3. 5 plus 3 is 8. And then minus 2. 8 minus 2 is 6. So I have 6 radical 7s. So that's equal to 6 radical 7. Now, when you have a problem like number 8, you may notice we do not have the same radical here. So right now, these are not like terms because I have a radical 63 and I have a radical 7. So if they're not like terms, you cannot add them together unless you can make them like terms. So I'm noticing that 63, maybe that can be broken down some. So let's check it out. If I type in 63 divided by x and go to my table, do I have any factors that would have a square root? 3 and 24 don't help, but look there, 7 and 9. 7 does not have a square root, but 9 has a square root of 3. So that's going to simplify to 3 radical 7. Now, we already have another 3 out in front, so that just gets multiplied by the 3 that we brought out because of the 9. So now I have 9 radical 7, and I'm subtracting radical 7 from it. All I did there was bring that one down. So now I do have like terms because these are both radical 7s. And I just need to see now how many do I have. Well, this is a coefficient of 9. And then if there's not a coefficient in front of that other one, you can assume it's a 1. So 9 minus 1 is 8. So that simplifies to 8 radical 7. Okay, if you like to chunk your assignments, this would be a good time to pause, and you should be able to complete 1 through 9. When you're ready to continue, just turn the video back on, or if you want to keep going, we're going to keep going. Now, in our next set of problems, we're working on multiplying. So when I simplify 4 radical 5 times 5 radical 2, I need to multiply those together. So I multiply the parts that are not under a radical together first. So 4 times 5. 4 times 5 gives me 20. Then I'm going to multiply the parts that are under a radical together. So 5 times 2. 5 times 2 is 10. So that gives me 20 radical 10. And then if I can reduce what's under the radical, I would, but 10 only has factors. Besides 1 in itself, we have 2 and 5, and neither of those have a radical. So that cannot be reduced anymore. So there's my answer, 20 radical 10. Now, same idea on this next one, but this one we're throwing some variables in. So let's see if we know how to deal with that. Once again, we're multiplying the parts that are in front together. So 4 times 2, neither of those are under a radical, so they get multiplied together to give me 8. Then I'm going to multiply the parts under the radical together. So 3x times 5x squared. Well, 3 times 5 is 15, and x times x squared is x to the third. Now, remember when you multiply variables, you add the exponent. So even though there's not an exponent here, you assume that's a 1, and 1 plus 2 gives me that 3, if you're wondering where that came from. Now, 15 does not reduce because the only other factors besides 1 and 15 are 3 and 5, and neither of those have a square root. But that x to the third will reduce, because if I divide my exponent of 3 by 2, I would have one pair of x's with a remainder of 1. So this is going to be 8x radical 15x when I reduce it. Okay, next, we're still multiplying, but you can see the problem looks a little different. This time we have a number in front of the parentheses. So what do we usually do when we have a number in front like that? Yeah, use the distributive property since we have addition right here. So radical 7 times radical 2. Well, both of those are under a square root, so I can multiply those together to get radical 14. Then I'm going to add, and what's radical 7 times radical 5? Okay. And neither of those reduce. 14 is 2 times 7. 35 is 5 times 7. Nothing has a square root. So those don't reduce, and I cannot simplify or add them together because I don't have the same number under the radical. So that's just my answer there. Radical 14 plus radical 35. Okay, next one, when we have radical 3 plus 5 and radical 3 minus 5, we are looking at something called FOIL. So FOIL stands for first, so we multiply first together. Radical 3 times radical 3 would be radical 9. The O in FOIL stand for outside. The outside parts are radical 3 and a 5. So that's going to be a minus since I have a minus here. And that's going to be minus 5 radical 3. I cannot multiply the 5 and the 3 together because if you'll notice, the 5 is not underneath the square root where the 3 is. So it just becomes 5 radical 3. And then the I part of FOIL is inside. So here are my inside terms. Positive this time, 5 radical 3, because that 5 has the plus sign in front of it. Okay. And then finally, the L stands for last. My last terms are 5 times negative 5, which is minus 25. And then I want to go through and reduce that. What is the square root of 9? Okay. And then here, those are like terms. One's positive and one's negative, so they're going to cancel each other out. And then I'm left with a minus 25. And 3 minus 25 is negative 22. Okay, next, the last couple problems are division problems. So this first type that matches up with number 17, when we're dividing, if you have two numbers that are under radicals, you can divide those out. So if you'll notice here, the 28 is under the square root, and so is the 7. So I can take 28 divided by 7 and end up with 4, but I have to keep my 4 under the radical since the 28 and the 7 were under the radical. And then what's the square root of 4? So 2 is your answer. Now, when you get to a problem like 18, this time we do not have two numbers that are both under a radical. We have the 1 that's not underneath it, and then the 11 is. Now, it's considered improper form to have a radical in the denominator. So even though that will not reduce, I still need to work to get rid of the radical that's in the denominator there by the 11. So I know in order to be able to have a number here to take a square root of, I just need to multiply that by itself. Okay. But whatever I do to the denominator, I have to do the same thing to the numerator so that I don't change the value of that fraction. Because look at this part in orange. Radical 11 over radical 11, that's just 1, isn't it? So if you multiply something by 1, you haven't changed the value. Okay. Okay, so once I've got that set up, now I just multiply the numerator. 1 times radical 11 is just radical 11. And then in the denominator, 11 times 11 is 121. So I'll have the square root of 121. The square root of 121 is what? Just 11. So that's going to simplify to radical 11 over 11. Okay, that wraps us up on 12.3. If you have any questions, just reach out.